We can call this slideshow continued, or we can call it slideshow 3. This is the picture that was up when we quit. So this little white wire you see here. It's running over to the foreman's house. That's our entire electrical supply. If we were to run a screw gun or a drill, electric drill, I don't think we'll ever burn up a power tool, because we probably only have about 160 volts out of the other end of this box. Between this and the transfer on the pole, 400 feet, 150 meters. It's a long way. Voltage drop is severe. Anyway, the tools never run hot. You can't overload them. It doesn't work the other way. If you put 200 volts in a 125 volt tool, you'll screw it up, because the windings can't take the current. But the other way around, it just has less power. Doesn't seem to hurt anything. And we've been using the same screw guns, DeWalt. Boy, I could have thought of it if I hadn't tried to say it. I can't think of the number. But we've been using them 3 years and have never put brushes in them or replaced them or had gearbox problems or switch problems or anything. So they're really underpowered. Electrically, the drill itself is very powerful. It'll ring off a number 25 torque screw if you don't pre-drill on hardwood. LANAIS 2. It's LANAIS 2. You could put a bench back here and see. This is natural ventilation from the house. It's working now, even though we have a phenolic board floor over the atrium. It leaks enough that we get the thermal chimney, and the air blows out here, and it blows out the other side. And also, you notice how this is tapered. This LANAIS is not straight-sided. That's intentional. It does several things. One, this walls are directly over top of beams on the living floor quarters down below. So this wall is continuous right down to the tie beam that's sitting on the ground at the bottom, the one under the house. So that's one. Everything is just stacked up. The load path is completely straight, and that's one reason why they're running an angle, because those walls run an angle. They're spokes of a wheel. The second reason they're running at an angle is that the opening out here is much wider. Cross-sectional area of where the air hits it is bigger than the air of the back wall. So that means that when the air goes through into this hole here, as it's just the natural breezes, it picks up speed. Air in has to equal air out. So the air coming out the back side is about 1.7 times faster than the air going in, and it goes through this hole into a room which is smaller than the outside, so there really doesn't get much chance to expand. But then it punches into the atrium, which is huge. It's 32 feet across. So that's when the air expands back to the free stream pressure from out here. And that's what sucks air from everywhere else in the house. And if there's any breeze at all, there's, I don't know if you'd call them windows. They're 24 inches high and about 1.5 feet less on either side than what you see here. So it's a rectangular slot. And any air on the top of the house that blows in one goes through and goes out the other. And that's flowing like a carburetor. It's like a Venturi, because it's also tapered like this. It's the same thing, just above it. Spider beam sits on top of this. Also, load path straight to the ground. The legs of the spider beam are on top of these walls, which are on top of the beam on the next level, which is on top of that poured concrete wall, which is on top of the floor, which is on top of the grade beam, the tie beam. So anyway, this house works by thermal siphon and by changing the shape of this duct. All this is duct. But you buy in concrete by the cubic foot. Your house costs by the cubic foot of materials. I don't care whether you're buying hollow blocks or you're buying poured concrete. It's cubic feet in your house is what you're paying for. The labor to put it up doesn't make any difference on what shape you make unless you're doing really fancy forms. Our forms are all straight. They're just rectangular forms. We bolt them together creatively, but they're just rectangular forms. They would do a square house the same as they do this Decagon, 10-sided. It's 10-sided because I asked my wife how many rooms we want. When she gave me the paper bag, which was the picture of her house, it had 8 sides. And I said, well, put the labels on the rooms. And she come back an hour later and says, I got labels left and no rooms to put them on. I said, oh, you need more rooms. She says, okay. And so the first thing we did is we counted the atrium as a room, and we wrote dining room on it. I'm not sure what you do in there unless you set it up like a restaurant with little like 6-foot diameter tables all over the place with like 4 or 5 chairs. You could make a dining room out of it, but it would look like a restaurant. It wouldn't be for a family dinner with half the people with their back to you. But anyway, we've called that dining room. And then she just added more wedges around here. And then I said, where's your electrical room? She says, you need a room for that? I said, I need a place to put security camera recorders and circuit breakers and just electrical stuff in general. Maybe someplace to lock up tools. So she says, you want to make it with 11 sides? I says, no, because I think the sizes of the rooms are starting to get small. See, this is like only about 24 feet right here. And that's 13 and a half or 14 feet. And it's 8 feet high. From there to here is 8 feet. The actual living quarters is 10 feet 1 and 5/32. It's just because that's what the height of the forms came out. We poured them to the top of the forms. Anyway, this shape boosts the speed of the air. It gets to expand after this door frame in here, and that makes it draw air from all around it as it tries to get back into its free stream pressure. And the warmness from the first floor comes up to the top, and the spider beam channels it out. It has to duck under the hub of the spider beam, so it makes it draw air from underneath of the spider beam rather than straight across if the channels were lined up. We haven't got the whole house fan built yet. I don't know if there's any videos on it. It's under construction. It's like 7 meters across. Like at Wilcon Depot, they have like 3 of them in there. But we decided just to build it. I'd rather give a guy a job for 3 weeks than to pay a company in China to build me a fan. I buy enough stuff from China. I don't feel bad about the Chinese not getting that little job. And it'll be custom. Anyway, you're buying your house by the cubic foot. There's a video on the comparison of price between a hollow block house and an all poured concrete house. They were both done to the thickness of a hollow block house with render. We made the poured concrete wall the same thickness as the rendered hollow block. So the cubic feet of the wall is the same. We made the top and bottom beams the same as we would make them on the hollow block house. So the physical dimensions of these two basically sample walls, they're 10 feet by 10 feet or whatever. The physical dimensions are identical, and the poured concrete comes out cheaper. Enough to make it worth doing, and plus you don't have to render it. We're rendering it because we weren't real careful setting the forms. There's some discontinuities, and it was more than we wanted to cover with skim coat. And we had the holes where in these things where the forms go, and they said, oh, well, she was worried that mosquitoes would just use it for a highway coming in and out. And we tried to plug it with mortar. Oka did. And in the morning, they were sticking out like extruded. They walked out because of the differences in temperatures between the plastic and the mortar and the plastic and the concrete wall. The plastic pipe stayed still. The fill came out. So I said, well, we had to do something to block that we can't have those things all sticking out like dowel pins out of the wall. Normally, you would use a metal rod that breaks off after you pour the concrete, and there is no hole. But there's another channel here, Texas Filipino. Filipino. Yeah, with O. Texas Filipino. He's doing slip forms, which are poured concrete. And he walked up and knocked them out. Now, I tried knocking ours out. I think he had probably knocked them out and put them back in for the video, because they did not come out here as easy as in the video, but they come out. And if my guys had not over-tightened the bolts when they put the forms together and sort of swelled them up like a barrel, they may have come out pretty easy. The few of them that came right out, I looked at them and they weren't distorted at all. And the ones that were really hard to come out and damaged the plastic pipes getting them out, those had obviously been swelled up near an end or in the center or whatever, kinked, all from over-tightening the bolts. But I told them not to over-tighten them, but I'd rather have them over-tightened than not have any breakout in the concrete and have these nice flat walls. So I got no complaints. But we're going to use the blue pipe, which is thicker wall, but we're going to go from 3/4 to 1/2 inch from now on. And that'll be easier to knock out, and it won't, if they over-tighten the bolts with the wall thickness twice as heavy on that size. The 3/4 Schedule 600 and the Schedule 1000 blue pipe, they weigh about the same per foot, cost the same per stick. So that'll work better. And that's what we'll do. But Texas Filipino showed me that. If I'd have known that, I would have got somebody to knock these things out of the wall, even if they come out in shards. Just give them a bigger hammer. You can't hardly damage a poured concrete wall. I don't care what you do. It takes a jackhammer to damage it. But we could have filled these and not rendered the house. But it's rendered now, and they gave people something to do for about 4 weeks. We had 4 to 6 guys working on it for 4 weeks. But you got to remember, this is 3,150 square feet. It's not a really small house. Okay. Could not stop my artists from trying to cover up basically little bits of honeycomb and stuff. I think this really is got the bump in it you see there. I don't think that's camera distortion, but there's some places that weren't completely smooth. There was one right here apparently. And this is all changing to a much smaller thing. This is there's one of the rooms that bumps out instead of bumping in, and that makes the roof have to offset, so we keep the same meter of rain protection, so no water will blow in. We never close the windows in the house we stay in. The time we get here to the time we leave, they're wide open. And we have, rainstorms like I have in the Philippines. It's rubbing down the street 3 inches deep out there, and down our driveway about an inch deep. But we never get any wet curtains or water on the floor in the house. And this house, a lot of the floors are wooden parquet, so you really don't want to get them wet. So I just copied the amount of overhang and the height above the window openings. And our windows aren't as tall or as big as they are in the house we stay at. The ones in this house are smaller. The one we're building are smaller. But we have natural light everywhere. This is just a regular room between Lanai 3 and Lanai 4. On the outside of Lanai, you have a wall going through there. And the other end, which would be over here, you have a wall going across. This is a structural consideration. If I could put a wall from here to here and one beside it, like in the artist's conception of this house for the building permit. These walls were hooked end to end, which takes more concrete. It was a more expensive house than this because our walls are shorter. And these would have been interior spokes, so we haven't lost or gained on that. Only the other wall gets shorter by about half. With the weight of this bunch of masonry and the weight of this wedge of the house is sitting basically on 2 beams, one under this corner and one under this near corner here. Hey, anybody notice that I've got the camera positioned where you can actually see the screen? What I'm looking at and what I'm pointing is on the camera. the last video I did an update on the plants growing on the porch. We're starting seeds out there for an orchard. And that one wasn't so bad. It's because I had the camera backwards. The one in between was the water pump for a deep, shallow well. If you have a 50-foot deep dug well and you want a hand pump, there's a video there how to build a hand pump that goes in the bottom of the well, and you can bring water up 70 feet no problem. Normally you're stuck at 27 feet because that's what atmospheric pressure is. And this was done on the same day as a couple previous videos. He's putting the X across his parts, and then he'll punch them, and then he go to Joe Mel to drill. And all these patches you see, that's trying to hold those sawhorses together. There's about twice as much weight in patches as there is in sawhorses. I had to put them together with carriage bolts because it wouldn't hold screws or nails. I got them together, and before I could move them out to the field where we were going to build the house, because we really hadn't started yet, bugs ate the bottom, I don't know, 6 or 8 inches off some of the legs, and the things only weighed half what they did. So we started patching them and adding pieces to them, but they kept falling apart. So we come back and put carriage bolts in them to bolt them together, trying to salvage some overpriced wood. I should have thrown them away. But these guys just keep adding patches. There's 1, 2, 3, 4, 5. I can't see it, but I know there's doublers on some of the legs. What a mess. This is the new construction stairs. I wanted something that would bear on this floor up here, so they wouldn't just slide off and fall when somebody's walking up it. And that's why these are sticking out like this. This is the sides of it are the forms from the spider beam. We used them for the spider beam once, and now we're doing we're just using them for all kinds of things. Anything that's less than that thickness, we use them for edge forms for floors and whatever. But I took 2 of them on each side and stuck them together, which made us 24 feet. And that's how long these staircases are. 1, 2, looks like 4 boards, 4 inches wide. So that's a 16-inch wide tread. And they're all that way with 7 inches of rise. Getting the mixer over this bump, we have a piece that lays up here out onto the floor, about 10 or 12 feet long, piece of solid wood, and that makes this a non-issue. I'm sure that you could get some guys and wrestle it up over that, but when that tire goes over that top, I don't want anybody on the other side of it. And I can't see how you would do it other than pulling up on it. And if they jump to the ground, that's about 12 feet down to the ground, and right now there's a concrete gutter down there, so nobody's allowed to jump off the house. This concrete cover here, this is the cover, a hole where we didn't pour, because we want to put a hand pump on the kitchen sink down below it, and we needed a place for our where we used to drill that well through the kitchen counter and into through the ground underneath of it. We're going to put about a 40-foot deep hole there and put a hand pump on it. Regular standard one like you buy for the bearing guy. Doesn't work, I'll make one. But we're gonna try to use a something that looks more architecturally pleasing than what I make. Mine's gonna be made out of pipe fittings. There's a video on it. It's if I don't say so myself, it's a slick pump. It really is. This here is the CR and a bathroom. There's another half to this house on the other side you can't see, and this is a room out here on the front too. This is where boy lives on this side and boy lives on the back side, him and his daughter. His wife was working for a casino. She's an accountant for a casino, so she stays up there most of the time, near all the time. And the little girl and him stay down here. These boards are not that crooked. There's no way somebody could walk up and find 4 boards that shape to put side by side. Here's another. 1, 2, 3, 4, 5. No way. The camera does that somehow. I'm not sure how. The handle over here is for looks only. Don't touch it. If you knock it off, you're the guy who's going to put it back. It's something to grab as a last-ditch effort. I don't know how much it'll hold, but it's not going to hold anybody walking up and down and leaning on it and jerking on it. This is what phenolic board does if it gets wet. This piece of phenolic board got left outside after we were done pouring something, and that was a facing on one of our main concrete forms. So you put a 2.5 millimeter cobalt bit into a regular electric drill and just rattle it around in a Torx head screw or a square head screw, either one. You put your bit in, wind them right out. So there's 90 screws in this into a Narra frame, and we flipped this one off and put another one up, and we got a pattern which is all the screw holes, and we can turn it left to right because all the pairs of screws are on a 45. So when you flip it over, you get a whole new set of places to put screws. So the first change on the phenolic board, if you change in once, you get a brand new place to put screws. And they're all pre-drilled in the phenolic board that you're adding. We drill them 3 at a time. And after that, well, you have to raise it up or down, or just use the screw holes, and instead of using 2-inch screws, we have 3-inch screws that are not T20 but T25. We have them bigger diameter, and we also have them T25 head, but the same diameter as a T20 screw. I just bought a variety. I shipped them over in a Balic Bion box, 25 pounds, 12 kilos, a little better than 12 kilos to the box. Anyway, this is not that crooked, and we didn't bandsaw that stuff to make it look odd. That's our wonderful hand drill. This is the splice. It's a 32 inches by 48-inch piece of plywood. And this down below was a frame that held all that together while we leaned it up. Some of that we pirated that coca lumber to use it for something else, and we put some stuff back later. They didn't like it off of there, so they went and put some. Trying to escape, but it's really slow. We'll catch it before it gets very far. I'm not sure where it's headed. It looks like it's headed down to the septic tank, or where we plan to build the septic tank. And that's it closer up. There's a video, a short piece and then a longer piece video about these mixers. And yes, I would buy another one just like it. In fact, I did. It's up on the roof. We keep one up there and one on the ground. If we have a big floor to pour, we get them on the same level. But basically, we just swap the motor back and forth, or whatever part broke. It's easier than dragging them up and down. The axle over here has a lot of bearing failures. They're ball bearings, not tapered bearings. And the ball bearing race breaks, and then the whole thing falls off. And we've had the stub axle, which is welded to a little, like a bolt washer, and into the end of a pipe. They put the bolt through the washer, weld the head of the bolt to the back side of the washer, and weld the washer to the pipe. And believe it or not, that has held up. The first failures on these mixers between 80 and 84 bags mixed, 84 mixes. That one hit at 84 and one broke at 80. The second one broke at 80. And the problem on that is there's a pipe spacer. It's also what the oil seal runs again on your drum, but it's just a piece of plumbing pipe between this build-up U-shaped thing that's the frame of the mixer and the bearing that's inside. It's the bearing spacer. And what happens on the other end, you can't see it in this picture, there's a gear running on this big gear. There's a pinion gear runs on this ring gear. And when you tilt it over like this, the clearance is too high and it goes and doesn't turn. And when we pour our concrete out, we never stop the mixer. We let it run, you know. So if we're pouring it into buckets or pouring it into a heap, we still let it run. We don't shut the motor off just to dump it out. So it would burr those gears up in no time if you didn't think. So what you do is you don't tilt it over all the way, or you wrestle with it. But the quick fix is this one nut holds the whole thing together. You bring it up level, put the lock on it with it level, take the nut off, and you get about 2 2x4s under here, and 2 guys on this side and 2 guys on that side. And these guys walk forward and those guys walk back. And the drum comes right out of that hole. It's not in there with anything. It just comes right off. And I think we pulled this, the pinion shaft. We take the nut off and pull the pinion shaft out. And when we have it apart, we put bearings on the pinion shaft because they failed 120 bags. So if we're pulling it apart at 80, we put those bearings in there. They don't cost much. They're a fairly large bearing. The OD is like 3.5 inches, or maybe 3 inches. But you take 6 millimeters off of that, the length of that pipe spacer, and put it right back together. And you're good to go for another maybe 200 bags. And then for one reason or another, you have to take it apart and take another 3 millimeters off of it. Both of our mixers, built by different companies, but exactly the same patterns, both of them required 6 millimeters. And that was determined by how much space was between the pinion gear and the ring gear, when it was standing straight up and down. You mix it with it at an angle. But basically, to measure it up, I put it straight up and down. And I left about 4 millimeters of clearance, 3 to 4, and took the rest off the pipe. It just lowers the one gear onto the other gear. It was really slick. And when we had the mixer, had the whole axle fall off, but the bearings hadn't broke. On that one, I got a piece of solid cold rolled steel, turned it to fit the inside of the pipe, fit in there about 4 inches, and turned the other end down. And then we replaced the bearings in the hub here with pieces of the same shaft, just turned into bushings. So it's a steel bushing running on a steel shaft. I couldn't take this to Manila behind a car or something. It's got no bearings. But these mixers are not ever going to leave this property. After I put 500 bags of concrete through them, I wouldn't wish them on anybody. They're going to retire out here in the field someplace. So I don't need bearings in those wheels. Now, the bearing failures in the wheels, that's on me. I caused that. Reason being, I see mixers with flat tires all the time. So I brought a hand pump out there, and I handed it to one of the guys, says, pump these things up hard before you start. And so the tires was up to about 40 or 45 pounds of pressure. Everybody else's mixer, the tires are half flat all the time. You can see them all bulged out in the side like radial tires. And that lets this thing move back and forth. And it takes the load off of those bearings. My tires were so stiff. All the beating and banging of the mixer trying to shake back and forth was right on the bearings. It failed the bearings, and it failed the attachment between the axle and the tube that it fits into. The leaf springs are welded to the thing, and they're welded to the mixer. And they put them on one layer at a time and weld every one of them. So you lay under there with a metal cutoff wheel on a 4-inch angle grinder for half a day to get that axle off. So when I broke one side, had to take the axle off, I just sent it to the machine shop. We weren't doing welding on site at the time, and couldn't get anybody to come out here and weld worth a damn. So we just took this axle pipe off, and we put it back with bolts. Says you can't learn. This is up near those construction stairs. It's just showing the relative size of the scaffold frames. Here's 2 of them like here. What a shovel. That shovel's not stuck in the concrete. It's wore off to that shape. And this is one of the windows going in. We put the screens right over the windows, inside and out. There's the same 2-inch welded wire mesh on the other side of the wall. That's why we were tying the screens with wire side to side. And then we found out that this washers and concrete nails was much better. And not only that, it was about 3 or 4 times as quick. We're to a good length to stop. We're going to end this video and take up here in a few minutes.